program in a South African audience. So my passion really is about that moment when most of us sit back in our chairs as executives and we'll ask ourselves, what the fuck do we do now? Now that happens a lot in this country, right? Not just with the technology that's coming at us at 100 miles per hour, but many other challenges. These problems turn into opportunities. Now how we've got to look at this technology that's coming at us is that there are opportunities. And what I'm passionate about is really trying to understand what is the impact on our industries. How do we as businesses react? Because it's all too easy to see the train coming and watch the train walk straight past you. But how do you do something about it? How do you not become the disruptor, the Kodaks of the world? How do you become the next Ubers in your industry? And there are ways and means to do it. I've spent 10 years of my career working for Silicon Valley businesses like Google, Bob, Android, YouTube in Africa. And what I've learned is that we can make use of all these trends and scale our businesses, no matter what business it is, no matter what region it is. So my passion is saying, my passion is really about how do I help South African businesses figure it out and transform. Then the next most important part is really about you guys. What do you guys do? Now you probably see a million keynote speakers telling you these incredible things, and you walk away, you go home, you eat your dinner, you go to work the next morning, you open your email, and life continues. Now this WTF moment is really about that. When you're sitting there and you're asking yourself, what do I do? You can either choose the path to continue doing the same old thing. Things will be okay. Our growth rates are fine. Our revenues look stable. Or jump right in with both feet. Figure out how you yourself are going to become a digital person. How you're going to transform your organization and take over your industry and become a global player in this new ecosystem. That's what I'm all about. Now I'm going to start this journey with a very quick story. Everyone knows the spice route, right? Hundreds of years ago it was. And it was actually a dear old friend of mine, David Roberts, who told me this story the first time. And I thought, that's amazing. Because we sit here in today's world and we stress about this disruption and we don't know what to do, yet it's been happening as long as evolution. How many of you guys have wisdom teeth? Just a quick show of hands. Not pulled out, but I mean you're born with wisdom teeth, right? How many are you born, okay? How many are born without wisdom teeth? You're the real disruptors, right? You've changed, you've evolved. Evolution happens so slowly that it's disrupting. The rest of us are Neanderthals. We're the ones who are going to be disrupted unless we pull them out. So this disruption's been happening forever. Now the example in the spice route, what were they doing? They were literally trying to preserve food. They were going to the opposite ends of the world, gathering up spices, and trying to preserve the food by making it taste a little bit better. They had ships, they followed routes. It was really an interesting career to be in, right? You can picture them recruiting people. What a great place to be. But now the spice route was disrupted, obviously, by the ice route. Now the ice route did not, or the spice route people did not see the ice route people coming along. You can imagine, they all had the same ships, probably following the same routes. And what the ice guys realized was, well, when we go to the cold regions, why don't we gather some ice, put them in our ships, and we'll take it to our customers. And we'll store it in these big warehouses where we'll get people to bring their food, and we'll preserve it a little bit longer. Okay, you can imagine, they had to innovate. Your first couple of trips, they got to the end point and there was a puddle of water. So they went back and they insulated their ships, they tried again, and the ice lasted longer and longer. They put it into these warehouses, and you were able to preserve your food. Now, who disrupted the ice route? Well, that's obvious. You've got these guys who are sitting there going, we're going to travel 1 million miles to get ice, or do we just make it here? We're going to make ice, and we're not going to put it into big warehouses. What we're going to do is we're going to create these ice boxes in people's homes. How convenient. You can store the food in their home, put the ice at the top of the ice box, and everything will rock and roll. Now, the time periods between these disruptions got shorter and shorter. No one saw each other disrupting each other. Literally, they were almost wiped out every time. It's pretty obvious who disrupted the ice manufacturers, right? Refrigeration. Now, because it's so obvious, and because it's getting shorter and shorter, does anyone want to have a guess what disrupts refrigeration? Anyone? Come on, it's easy. Really, it's easy. You guys in the game? It's drones, of course. Right? It's not that easy. So what's happening in Silicon Valley? What they're doing is they're trying to shorten that food delivery time. We hear so many stories of guys disrupting the delivery service market by being able to deliver food to where you are, or deliver food to you in under an hour. And in fact, Amazon's demonstrating or trialing in San Fran 2 points where they can deliver anything to anywhere in under 30 seconds. Now, who's the Neanderthal now? Storing fresh food in this whole area in your house. Sis, man, it's rotting. I'm going to get onto my mobile phone, and I'm going to order the food, and I'm going to reach out the window of my apartment, and my banana will arrive. It is so obvious. So this disruption is getting tighter. We've seen it often. In fact, all of you have seen the disruption in the last 5, 10, 15, I'm looking around the room, 20, 25, 30, especially in the era of storage. Who was around? Who's seen the era of the floppy that went on to a stiffy? God, I've got to question the marketing terms here. Floppies that became stiffies, at least they got the order right. But look where storage is right now. You're no longer going to put it on a device, you're going to rent it in the cloud for 12 South African cents per month. For a gig, it's nothing. We've actually seen it. We've seen the effect as normal human beings of Moore's Law. How many of you have planned your businesses around Moore's Law, where technology doubles every 18 months and there's another law attached to that that says it halves in price? So what are these trends? I actually don't even call them trends. This is what's happening right now. The reason why everything is changing so quickly is you can buy compute on a credit card. You might have heard of things like cloud computing. What's really impressive about cloud computing is not the fact that there's lots of computers. It's the fact that I can take my credit card, I can open up access to as much compute power as I want, and I can go disrupt Google if I choose to. So in Google, we were paranoid about a 2-person business coming in, buying our own hardware, and disrupting us in 2-3 months' time. The barrier of having computer systems and hardware like at a bank, where you have huge data centers, and that was your barrier to entry, is gone. Anyone can get unlimited compute in their pocket. So what else is changing? Because we have unlimited compute, the field of artificial intelligence, which has been around for 50 years, ladies and gentlemen, there have been scientists trying to figure out how do they make computers more human. This point is called singularity, and they're estimating it's now around about 2045. Ray Kurzweil will make the estimates. And I think it's a pretty good estimate. Because when you see things like this game is called Go. Go is a very advanced version of checkerboards and chess in China. Now, a little team called the DeepMind team, who's part of the Google ecosystem, decided they would build an artificial intelligence unit that would beat the global, the world champion at this game. Now, what's impressive is that they've used petaflops of compute power. And that's so much compute power, it's like 1 million servers in a data center. They used data that Go players could give them that had on record, and they trained the machine for 40 days. And they beat this Go flag. And it's a landmark kind of decision, because what was happening is DeepMind started figuring out its own moves. It started being creative. It started teaching the best players in the world that there are different moves that can be made. What's even more scary is 3 months later, AlphaGo 0, that's the algorithm's name, was rerun. This time, they used 3 machines. They used no data. They told the algorithm, please just learn what the rules are, what the win state is, and within 4 days, it had figured out how to beat the AlphaGo champion. That is scary. That's the speed at which technology is advancing. I don't know if anyone's been talking about blockchain today. Who's bought some Bitcoin? Who sold their Bitcoin? Who sold their Bitcoin way too early? Am I the only one? Come on, there's got to be someone else in this room, right? In fact, I always make myself feel a hell of a lot better because one of my team, a guy called Kimoon, had 100 Bitcoins 7 years ago, used it to buy skins in his game. And he was like, I don't know if I want to play this game anymore. He had the certs on his machine, sold his machine, never could find his machine ever again. When I'm feeling bad about my decision to sell my coins, I remind Kimoon of the price of a Bitcoin. Now, Bitcoin, crazy, purist, seriously, there's no real value attached to it. The interesting part is the blockchain. Now, it's not the Bitcoin's blockchain. There are many types of blockchain. And it's distributed ledgers that are going to change not just our business world like supply chains, but it's going to change what the internet is. We're about 1996, and the timeline of the internet is the timeline of the blockchain right now. And Ed's going to share some really great examples with us a bit later around this. Guys, very important in this industry that you understand what's going on in the world of blockchain. Lots of geeks saying lots of crazy acronyms that are scaring everybody. So, a space to watch. The next part is IoT. Everything's connected. That's great. Well, what does that mean? It means that the interface to this connectivity is becoming more like voice. When you order everything through your voice with a Google Home, does anyone stop the Google Home here? I always say stop the technology, guys. Go the cushion, the chair, the lamp. Sorry?
It's on the table.
It's on the table, right? In fact, the chair, the cushion, the lamp probably could be the intelligence soon. But it's on the table. I remember the first time I bought my Google Home, and I asked it, okay, Google. And I went, hello, great. I was like, how's my day? And she went, your day's crazy. The weather's like this, and your diary's a mess, and the traffic is a disaster. And my wife, as I put her in the kitchen table, kind of strutting around the kitchen table, what is this technology that's in my space? I'm like, come on, darling, we've got to learn to change with the times. And I remember waking up the one morning, and there was this Facebook post, and on that Facebook post, she's got a selfie out. Ladies, what is book club? What really happens at book club? Maybe that's the question. Because she was definitely book clubbed. And she's a bit slurry, and she's talking to the OK Google, and she's casting stuff, listening to music, and loving it. And she posted under that video, I love my Google Home because it's the only thing that listens to me. So times are changing. It's impacting how society operates. I'm going to share with you a very quick video. It's 2 minutes. And it's going to share with you, it's going to give you an indication of where this technology's gone. It's become so lifelike. It's quite scary.
A big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we're working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
Hello, can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what am I looking for? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day, bye.
So guys, this world is in a state of fast, constant change. We've got artificial intelligence talking so real. They've designed a personality. They understand in real time, because of the unlimited compute, how to respond to what's being said to you in a human-like form. So then you start thinking about the applications of this in a call center. And you get excited. You think, one day, you're going to have, instead of having, that tree, decision tree, press 1 to go to this, press 2 to go to that. You're going to have someone talking to you. Hi, Brett. Hello. I'm an automated robot. How can I help you? I see you made an order with us. I see you'd like to do something with it. I'd like to cancel it. Fantastic, we've done that for you. That's where it's going, or is it where it's going? Because 2 weeks ago, it was announced again, 2 weeks ago, at a Google event, that that's now a reality. So anyone can log on with their credit card and start replacing their call centers using this Google Cloud technology. We're entering a world of fast, constant change. So if we look at our own businesses, how do we start changing our businesses, not just to take advantage of a trend? How do you continually change? I think of my days in Google. I had 13 bosses and ran 7 businesses in 5 years. We were in a constant state of change, always getting better. So how do you do that? Well, the first step is you've got to make data your friend. And I don't mean your Excel spreadsheets. I don't mean some monthly reporting. I mean every element of your business. Every piece of fruit, every grain in your business. Know exactly where it is, what it's done, how it's performing, and start forecasting outward. That's where you need to be. That's what a Google or a Facebook or an Airbnb or an Uber operates their business as. How data-driven is your business? How fast do you react? How fast do you implement changes? The technology is there to switch on and off in a click. This is a great example. This is a real GIF. This is the Mercedes team, I think.
Williams.
And what they did is they reduced the speed of a pit stop from 4 seconds down to 1.92 seconds by understanding the data. I'm sure a lot of their teams did lose a lot more weight, right, to move around that car very quickly. But you think you can't go faster than 4 seconds? You can. With big data, with artificial intelligence, I bet you they're going to get faster than 1.92 seconds. So 3 things, chaps, ladies. First thing, this is to help you. Don't be a Trump. It's an obvious one, right? What I mean, I don't think any politician out there, by the way. What I mean is, don't be the butt person. I want you to think about that. So many South Africans, we say the term, your butt. Guys, let's go do this. It's going to be incredible. Let's try that. No, but I've got this project to deliver. Your butt. We've got a bunch of stuff on the side. I can't move it. Your butt. How many do you say that? Call yourself out and call your colleagues out. There are other terms like now or just now. Very dangerous for fast innovation, right? What is right now in South Africa? Does anyone know what that term is? I mean, dead serious now. Like today, like now. You've got to invent that term. Not now, not just now. Then do it. How many of you guys use Instagram? Show of hands. Who feels like they're an artist? An artiste? You get Instagram, and I was also one of those. I was like, oh, that's for the kids. And I realized I had grey hair, and I thought I better get onto this a couple of years ago. I'll do it because of the kids. But now I look into the corner, and I see this beautiful, incredible piece of work of art, especially with a certain filter on it. My life has changed. Thank you, Instagram, for opening up my eyes. But the message is, if you're not trying the technology every day on your supercomputers, in your pockets or your handbags, then you stand no chance on bringing this into your organization. And finally, think big. Elon Musk does it. And he thinks too big. But thinking big means take away those boundaries, those constraints. Well, I can only do this because I only have X amount of time. I only have a certain amount of budget. Remove those. Start solving problems with unlimited budgets, unlimited access to whatever you wanted. Solve the problem that way, and then apply the constraints of the box. Think big. So ladies and gentlemen, on that note, now what the fuck do we do? Thank you.
Thank you, Brett. Now I'm going to do a little dive into blockchain. And I do have a guest speaker who's joined me. Dan joined me in China when we did a similar presentation at the PMA Fresh Connections in Shenzhen in March. And since I found out he was here, I'd asked him to join me in this presentation again. So, can you get the presentation up? There we go. I'm going to cover what is blockchain from a produce guy's perspective. I try to simplify it and put it in terms that I can understand. I will talk to you about some pilots that are underway, specifically in the U.S. And then Dan's going to talk to us about other applications, specifically one that his parent company is involved in. He'll cover the issues we think need to be addressed. This thing's brand new, and this baby's just learning how to fly right now. And then I've got a couple of recommended steps for all produce companies. So blockchain, it's a continuously growing list of records, that's a block, that are linked. That's the chain. Blockchain. Very simple. The data is secure. You can't change it. It uses very sophisticated encryption protocols. That's a fancy word for saying it creates a unique number, serial number, hash number that incorporates the data, the time, and creates a code. And because it uses distributed ledger technology, that it's not one central database, and I'll cover that in a minute, no one can modify it, because you have to modify it on everybody's computer. You don't know who has it. So virtually, it is yet been hacked. Impossible to modify the data without people being aware of it. So it's a protocol. So it's not a database in the sky. And I get people coming to me all the time. It's not a software. It's not a hardware. It's a That's all it is. It was created a few years ago, and Bitcoin has been the most, and the first and the most famous application using it. But it's just a set of rules that says, if you're going to share data, here's how you share it. And here's what you need to do to make sure it's authentic. The beauty for our industry is it now allows data or information around that product that you're harvesting, that you're packing, that you're repacking or shipping or receiving. It allows data associated with that particular shipment to move at the same speed as the shipment does through our very complicated supply chain, or as I refer to as supply web. And I know we use EDI transactions, electronic data interchange, for invoices and purchase orders and advanced ship notices. And that's good for the center of the store and those other commodities that move very slowly, that may take a week from the time you place the order until it shows up, and that's fine because you've got 3 weeks inventory in the warehouse. Our product, fresh produce, is much different. A lot of times, the truck gets to the retailer or food service distributor's DC, and it's unloaded and put away, and a few hours later, the electronic advance ship notice comes. It's no good to you. It doesn't move as fast as the product does. A brief slide and centralize, that's where one company owns a database. That's it, and you log on to their database, and you do your things, and you get off. Amazon's a good example. You buy on Amazon, you go onto their database, you don't do yours, you won't have a copy. Distributed is where the data is on multiple databases, but there's one central router that controls them. So it's still controlled guard. The decentralized, the bottom section there, is the same data is on multiple computers. So everybody's got a copy of the same data. That's how blockchain works. It works in that bottom environment. So it's just a ledger of transactions. You can't change it. You can't delete it. Once it's on the chain, it stays on the chain. It's a secure database or ledger, copy on multiple computers. Everyone's got the same copy. I put this together trying to explain it to myself. So if you look at the, start in this, understand this is the most simplistic produce supply chain you can get, and most of our supply chains don't look this simple, but in this example, a grower, he puts into his ledger that gets transmitted to the blockchain all the information that he's comfortable with sharing. So you may want to put the lot numbers of the seeds, and when he planted, and what crop, and what variety, and what applications he put on the product, and when he harvested it, the location of it. He puts all that information, whatever he's willing to share, into his ledger. It then goes through the next path to the packer. Well, the packer has the grower's data, and then he adds his data. What did you do with that information that the grower gave you? Well, I packed it into 40-pound boxes of navel oranges, and his lot number was 1, 2, 3, 4, 5. My lot number is whatever the Julian date is, today's date, and that's my lot number. And here's the item number that I've assigned to it, and what I've done with it, and where I put it, and what packing line. And you can put employees' names and the time of day, and if there was any product that got discarded, whatever you want to put into that ledger. Well, that ledger is chained to the packers. The grower and the packer, that data is linked together. That's how it's chained. And then it goes through the supply chain. The trucking company probably wants to put in the bill of lading number and the temperature and condition monitoring that he's got for that particular load, maybe the route, the driver's name, the unit number, the trailer number, the tractor number, the address he picked it up, the address he delivered it to, whatever information he wants to share, and so on and so forth, through the supply chain all the way to the store. So that at any point, people can unlock that data, as long as they have the right permission to unlock the data, and look all the way backwards to the beginning, to the origin of that product. and say, oh, for the first time, I now can see everything that's happened to that product. That's what was behind, and in theory, when Walmart entered into a pilot hosted by IBM. IBM came to Walmart and said, we've got this concept, and their chart, it's probably a little fancier than mine. You're probably better at PowerPoint than I am. They said, you know what, there's something to be said on that. Walmart in the U.S., #1 grocer, have, as all grocers in the last 10 years, have experienced a lot of category killer recalls. Spinach in 2006, tomatoes, which turned out to be jalapeno peppers in 2008. We had cantaloupes in 2010 and 11. Unfortunately, those killed 34 people, lost their lives because of cantaloupe hysteria. Walmart was involved in that. And then most recently, we've had romaine, E. coli in romaine out of Yuma, Arizona, which has killed 4 people. So they're saying this is not good for business, it's not good for our consumers, it's not good for our industry, where we have these category killer recalls. One operation does something wrong, and all of us suffer. And it costs human life and the cost and the disruption to the business. So it's okay, IBM, if you got a better way of doing this, great, we'll work with you. There was an initiative created in the U.S. called the Produce Traceability Initiative, where basically everybody put the same standardized label with a barcode on it on every case of produce, and people captured that information via the barcode as the product went through the supply chain, and that enabled you to do a one back and one up traceability fairly quickly. Walmart is one of the most progressive retailers using that initiative. Every case going into a Walmart store in DC has to be labeled with that label. Given that, they did a test. The VP of Food Safety for Walmart, Frank Yanis, went to a store in Bentonville, Arkansas, went into his office, or went to the store, bought a unit of sliced mangoes, put it on his boardroom table, told his food safety team, go. I want to know where that product, where it came from, and the whole history of that product back to the grower. And keep in mind, Walmart's one of the better companies at doing traceability. It took them 6 days, 18 hours, and 26 minutes to finally figure out where that unit of sliced mangoes originated in the path it took. They then entered into this blockchain pilot, and when they did the same store, a different unit, same item, but a different unit months later, sliced mangoes, they put it on the boardroom table. It took them 2.2 seconds to understand the complete history of that product right back to the grower and what other stores that product went into. Keep in mind, Walmart never took possession until it hit their DC at that point right there. But they were able to get visibility all the way back to the orchard in Mexico. They got so excited about the results, and it wasn't just the 2.2 seconds it took to do that traceback. One of the pieces of information that they really looked at was that product sat at the Mexican border trying to enter the U.S. for 4 days, sitting on a truck, trying to cross that border. One stage before Walmart took possession, because it went to a processor who sliced it, and then it was packaged, put in a case, and shipped to Walmart DC. Without blockchain, they would never have known that. They lost at least 3 days of freshness on that product because it was sitting at the border. They said, we're Walmart. We import more produce into this country than anybody else in the world. We can help you with that. We know how to do it right. We know how to get those trucks through efficiently. They don't bend any rules, but they follow them and they know the protocol. They said, we can help you. We would never have known that unless we were given this visibility of our complete supply chain all the way back. So they got so excited, they said, we've got to move forward with this. But to give them credit, they said, this is too good for us to keep it amongst ourselves. We've got to bring the rest of the industry along with us and figure this stuff out together. They did one pilot. It proved some really good information for them. So their credit, they stopped, and they could have done this a lot quicker on their own. They engaged Driscoll's, Kroger. Kroger's at number 2. Their biggest competitor in the U.S. They invited them to the pilot. Wegmans, number 18, the number one grocer employer in the country. If anybody ever gets to the Northeast U.S., I encourage you to visit a Wegmans store. It's an experience you'll never see it anywhere else. The largest regional chain, very, very good company what they do. They participated, and then Dole and Driscoll's, they also did, and they did a couple of pilots on different products. I focused on the produce. And they said, we together got to figure this thing out. We don't know, we know there's something there. So they got together, hosted by IBM, and don't fool yourself. IBM's in this to make money. They're exploiting blockchain. They were advertising on the Super Bowl about blockchain. They've invested a lot of money, but the results are very, very, very encouraging. They put these pilots together. One of the things that people who know me know I'm not shy. I'm a former retailer, 25 years in retail logistics in Canada with the number 1 and 2 grocers there. I found out about these pilots and invited myself to be part of their project teams. I have a blockchain task force, one of our volunteer committees, and I said, you're working with Dole and Driscoll's, all the respect in the world for those companies, but most companies in our industry are not as sophisticated from a data or a system perspective as Dole and Driscoll. So whatever you guys figure out, I want to make sure and be that voice and be that conduit for you to make sure that it's going to work for all produce companies, not just the ones with multi-billion-dollar produce companies. And they accepted me. I'm an adjunct member of the Wegmans and the Walmart blockchain pilot programs. So when they went through it, they went through every step in the supply chain, and they're quite adamant, and got to give them credit, and everybody sings the same song, saying the benefit to every point, anybody who participates with this pilot and with this concept, the benefit has to outweigh the cost, or it's not going to work. We can't do one of those initiatives where, and I was famous for it when I was head of logistics at Sobeys in Canada. I'm a retailer. I tell you to do something, you're going to do it. If not, you're not going to get a purchase order from us. Guess what? We got what we wanted. They said, no, we can't do that. That's not sustainable. We got to make sure we do this and we look at it and we understand where the value is in using blockchain and the information it's going to give us so that everybody who participates is going to get more out of it than they put into it. And so far with pilots that they've gone through, that's true. They have 2 pilots. The one they talk about mostly is the product recall, which is the example I gave you on the mangoes. It's traceability, but the more power is transparency. It's also accountability. For those other products that they're testing, they're doing some authenticity plays on that to make sure that, I think one of them is they're importing pork from China, to make sure it's actually coming from the people that they say it's coming from, and they're using blockchain to do that because all of a sudden, the exporter can't ship 400 cases when he's only received 200 from the pack. So blockchain is able to connect the dots for them to make sure that it is truly authentic product. I'm getting what I'm paying for from whom I think I'm getting it. They are also using existing business practices and existing standards. So they're realizing we can't go invent a whole new way of doing business to support blockchain. Blockchain's got to work on top of how we do business today. And they've done a very good job. They've incorporated GS1 standards, which is the language that we all use for UPCs and barcodes. The Produce Traceability Initiative that I mentioned, it's actually fundamental and a requirement for blockchain to work. They have to have that common label on the case. Everything's down to the lot number and the GTIN, the Global Trade Item Number, and that's the basis of all their data and looking at the data. The other one they're doing is certificate management. For a retailer to do business with the grower, they have to have a food safety audit on file. For the right product, it has to be valid. For the right farm, the right packing house, they have to have insurance certificates. They have to have copies of business licenses and operating authorities and all sorts of information. That process process to manage for a retailer or any buyer is a nightmare. You're managing literally pieces of paper or PDFs or emails, and it's hard to keep it current. It's hard to make sure that you've got it for the right product and it's there. They're using a blockchain application that is proving very, very beneficial for them. And I will highlight a little bit on one of the things they're including is food safety audits. Those are very hard to manage to make sure they're current, and most retailers' food safety departments spend most of their time chasing paper and documents and very little time analyzing the data that's inside that audit. That's where the value is. We had a task force at PMA that was addressing that problem. We created this thing called the Trellis Framework. It's a framework, set of rules for sharing audit data. So rather than sending a PDF of a paper document, it's actually sent in machine-readable format. It's open source. Anybody can use it. It's free. You want to know more about that, come talk to me or email me. I could go on for an hour just on that, and I promise I won't. But what that allows them to do, now they're sure they've got the correct audit on file, and it's automatic. Next time that operation gets audited, it automatically populates to whatever customers you want. It works very, very nice. And they're now linking the two. They're trying to figure out how they can link, okay, I've got this shipment with this lot number. How do I know which audit is applicable for that range, for that packing house, for that product? What sets of audits? So now one of the challenges they're doing is they're trying to link the two. This is really static data, it's stuff you typically have once a year. The other is dynamic data, that's for every shipment. They're trying to link the two right now using blockchain so they can validate when they receive that product, I have a valid food safety audit on file that's applicable to that particular lot of product I'm receiving. That's going to help them going forward. I was a little dubious on their statement of the benefit has to outweigh the cost. So I had a chance to spend a couple hours with Natalie Dynson of Dole, who's heading the blockchain pilot for Dole. She's the VP of Food Safety. And she told me, she goes, yeah, we thought this was going to be a lot of work for us and it was going to be one-sided and the retailer get all the benefit. She goes, trust me, it's not. The process of implementing this forced us to clean up our act. We found out we had a lot of data that wasn't accurate. A lot of fields where the salesman or the person listing the product just put 99999, fill the field, move on, get the purchase order, and carry on, and life is good. What they didn't realize was it screwed up the accounting department and required manual intervention all the way through their business. So she said that with blockchain, it forced them to clean up their data quality because it was obvious and it didn't flow through the system properly. And it highlighted very inefficient processes between their growers, their packers, and their shipping operations. When she said that one of the biggest benefits she got was they now had visibility right to the store of their product. Not just sales and shipments into the store, but they could correlate that to claims. Claims by the DCs, claims by the store employees, and claims by consumers when they called and complained about a gold bag salad. And they were able to identify, and typically, when the growers in this room, anytime a retailer, no offense, anytime a retailer has a problem with quality, it's their fault. Because they can never do anything wrong. Well, they said through this data using blockchain, they were able to identify in a few cases where it was one of the retailer's DCs that was mishandling the product or mismanaging the cold chain, which was causing a quality issue. She said that alone is proved valuable. She got called into her boss, the CEO of Dole's office a couple of weeks ago, and he said, how fast can you roll out blockchain the entire company? Because they just did a couple of ranches for the pilot and then limited basis. She said, how much money you got? Because how much you need? I want it done by the end of the year. They will be fully implemented company-wide by the end of the year because they saw so much value in it. I'm now going to hand or review, and blockchain, that's one set of pilots going on, great learning, great process that they're doing it collectively and collaboratively, and basing it on standards. There's all sorts of other pilots going on in the agriculture world, lots in Australia, lots in China. Authenticity seems to be more of a priority coming out of China. It's not just IBM, Microsoft's doing pilots, all sorts of people are figuring this thing out. It's moving fast. And not everybody's figured out exactly how it's going to work, what the standards are, but a lot of people are investing a lot of time to try to figure that out. I'm going to hand it over to Dan now, who's going to talk about another application that his parent company has using blockchain. Yeah.
Thank you, Ed. My name is Dan Stan. I work for Trimble and I run the Harvest Mark business at Trimble. And we have done a lot of work in the traceability area, and blockchain. Actually, we're a partner and open source co-contributor to the whole blockchain effort. We have a partnership with both IBM and Microsoft. And at Trimble, a lot of people, if you're in the X space, I'm sure you have used our GPS devices, leveling or machine guidance and all those kind of things. But we also have a lot of engagement in transportation, telematics, transportation management systems, geospatial, construction, etc. So the part of traceability is really this Harvest Mark business. You can see the customers we have. A lot of them are really the big name, both producers, growers, shippers, and retail and food services companies. So we have done a lot of work in the blockchain space. I think we talked about traceability, we talked about IoT, we talked about transactions. One big part of blockchain is the concept of smart contract, which is basically when you have multi-party transactions, let's say you have a buyer, a seller, the bank, and the insurance company, and the carrier, all multiple parties. Could be the government, the regulatory, it could be the custom agencies. When you have multi-parties involved in the transaction, you need to have agreement on the terms, on the delivery. What's beautiful about blockchain is you have all these contractual terms encapsulated in that smart contract, and that smart contract is sitting on blockchain, so you cannot change it, you cannot delete it, and once the conditions are met, the transaction is closed, then all the settlement will get triggered automatically, whether that's a proof of delivery will trigger the back payment, and it could be attached to a temperature condition, to the quantity, to the time of delivery. All those things could be quality, all these things. So that's part of the financial invoicing settlement, and then you can use the same information for your logistics and planning. And then the traceability data will come in, linked to the food safety data, to the location data, to the consumer data, and once you have all these things together, you can do analytics in it to help you improve your operation efficiencies, product planning, and that's really the cycle. And of course, you can attach all kinds of IoTs to it, sensors, and the devices all together. So I'm not going to talk a lot more about the Trimble involvement since I mentioned that. This is one example for the carriers. So in North America, there's a carrier called DART. There's regional carrier doing coaching engagement. In the old days, they all use, when at the beginning of the year, when the shippers try to get quotes from the carriers, that would have huge spreadsheets sending out what they call the lanes, the industry term, basically the city pairs, with volume that they're expecting for that year. And each carrier will fill in their part of the bid and say, for this lane, which is this city pair, these many loads, here's my price, quote for that, and the shipper will get all the spreadsheets back, and they do the massive reconciliation, and that becomes the contract. The problem is your forecast at the beginning of the year and the actual shipping loads and the volume throughout the year could be very, very different. And remember, when you ship something that's perishable, like produce, the condition and the temperature and the quality, arrival time, all these things can change. So to reconcile all these transactions at the end of the quarter, end of the month, it's going to be a huge problem. In the past, DART has 12 price mills just to do all these reconciling of invoices versus actual. With the blockchain system, what we did for them is we created a smart contract portal. Instead of sending the spreadsheets out, they just go on online and bid their lanes, with all the conditions in the smart contract. As the smart contract is memorialized in this blockchain, and when things are delivered, the proof of delivery will trigger payment, and the data is real time. So there's no more reconciliation at the end of the month or end of the quarter. And they were able to reduce the number of pricing levels from 12 to 3. So think about cost reduction. Beyond that, they were able to see where the demand is versus capacity. They were able to reposition the fleet to get $3.5 million more profit out of the whole operation throughout a year. This is because they have better matching of supply and demand. And so with the blockchain, we can track what is the load being shipped, where's the vehicle, who's the driver, where's the load right now, what's the proof of delivery, what's the temperature, and of course you can track them, along the way, not only where the product is, what's the temperature inside the truck, but also what is the ambient temperature, because in some of the places it can be super hot, where AC is not even rated to serve in that kind of ambient temperature. And in that case, the warning will get sent to the cab, and the driver will probably stop or reroute. And the ETA will get updated, and all these things will get changed. So, and so this was what we delivered last year, and they've been running this for a year and a half. What we did this year, we announced about 2 months ago, we had a production system with the Shy Vineyards, which is a very large winery in the Monterey County in California. What we did there is we implement the blockchain system that linked to the upstream grower, the grape growers, and all their information around the soil samples, the fertilization, irrigation, all those culture practices, weather information, all the way to the harvest and yield, and of course to the delivery time, and then to their wine processing and the brewing, fermentation process, and then down the stream to each bottle. So we can now link all the bottles all the way back to the vineyards where the grapes are grown in each variety of the grapes, and then all the way down to the downstream transportation logistics system to the retail, and the consumer will be able to scan the QR code on the wine bottle and leave feedback, but also learn about the food pairing, about the winemaking process. It's both the authentication process, but also the interactive process. And then they will learn, what Ed mentioned, not only the food safety part, but also where is the bottleneck in the whole supply chain. If the temperature during transit was off, if the wine was cooked, if there are any problems, is that at the inventory, at the distribution center, or at the retail? What is the consumer reaction by region, by demographics, by season, by wine variety, and which one has better consumer reactions? So that is what we're going to do, just to link everything from seed to consumer, even before seeds, from the soil to the consumer. And the beauty of this is you have the control of the whole supply chain. At the same time, you can control who has access to what information. It's on the blockchain, but doesn't necessarily mean that everybody has access to all the data. You can control, there's certain data that's open to your trading partners, there's certain data that you only give to people who you trust, who has authority to see that, like transaction data, like pricing data, like scheduling data. So that you don't have to worry about your privacy or information. That's what we're coming to about the issues to be addressed by the industry, like the supply chain data, transparency. What do you want to share with the consumers? Right? You don't want to share all the stuff, all the detailed transaction information, the cost information, not that. What data should only be shared with trading partners, right? And there are certain things you want to share, but certain things you don't want to share, right? Your private cost data, your own production data, any trade secrets you have, or any third-party information that you are not allowed to share, right? And there's discussion about public versus private networks, private chains, their cost, performance, and ability to select privacy levels. I have to say, public chains are, example of all Bitcoins and Ethereum and all these coins, they're on public chains. But most of the industrial applications are on private chains, which means it's a private consortium. You need to have user ID, level of access to participate, and you need people to confirm the transactions so it's not open to everybody and anybody. So that's the level of security. And the other thing is that we're doing a lot of things about chain-to-chain communication about the information and identity management. Why that's important? Because it's hard to think about putting all the data in the world in one single chain, because that chain is going to be so slow. The transactions will be too slow to be meaningful. So the way we're thinking about the world is multiple chains, and chain will tackle each part of the value chain, part of the industry, and then there will be data interchanges, exchanges across chains, but you need to have some sort of identity management process to authenticate all these things. And the other things we're thinking about is to have off-chain versus on-chain data to avoid this data overload issue, because a lot of detailed data, you don't really need them to be on the chain. It's going to grow exponentially. It's going to slow everything down. But the beauty of the blockchain is the hash, right? The hash is really the hash. You hash the data down to a single key. With that key, you can authenticate the data off-chain, still valid. You can, if you want to have that, you can access that, but you don't have to keep everything on the chain. So with that thing, we think we can get the transaction much faster, get the system more effective. All the trading partners will benefit, and the regulators will have access to the right blockchain data. That's another question to ask: is what data do you want to share with the regulator? And there are some recommendations to the produce company, and I will cover that.
So my recommendations, when people ask me, okay, what do I need to do? I'd say, well, figure out there's a business process that blockchain's a solution is going to help you solve that. It won't solve everything, and it doesn't apply in certain things. You need to figure that out. Understand who you need to partner with. Figure out what the investment, figure out what your benefits are before you even enter into it. You got to be aware of what you're looking for. Start small, and then grow. Prove it. Prepare your business. Get your systems ready to post information to the blockchain ledger. The train has left the station. The blockchain train is gaining speed. It's coming to you soon. Unpredictable. Figure out the best method to capture your information. If you're that grower I showed in that slide, a lot of the records you have are probably handwritten records. That's not going to cut it going forward. You're going to have to figure out how to get the data from all the different systems into one common ledger. Once you figure it out once, it shouldn't be that difficult. And that one, if apparently capital is bolded, is yelling, I'm yelling. Update and document your company data sharing and privacy policies. You should be doing that today, but blockchain is going to elevate that need in a hurry. Because once you put your data on there, whatever data you're going to put on, you need to understand and have rules around who can see it and who can share it. Just because you give it to a customer, a retailer, you may not give him permission to share it. You need to really, really have a serious conversation with all the right people in your business and figure out where that line in the sand is. It says, I don't care if you want that information, Mr. Retailer or food service company. I am not going to give it to you. If that means I'm not going to get a purchase order from you, that's fine. You need to understand where that line is. And then you need to build processes in place in your company to make sure that your road salesman trying to make his quota for the last day of the month is going to give information that you and your data policy says it's not leaving this company. I have seen companies ask for employee identification, social security number in the U.S. of every employee who touched this product. That broke so many rules up there, and people they pushed back and they said no. And then, well, I want it just in case I ever get questioned. Is everybody ethically treated and proper citizenship and documentation to handle my product? Blockchain makes it so easy for people to say, just give me all the information. I don't know what I'm going to do with it, but I got it and I need it someday, I'll figure it out. You really need to focus on that. With that, I'm going to turn over to Chris. Okay, thank you very much, everyone. Look, it's a great privilege to be able to talk to you a little bit about what we think is happening in the way of technology and the digitalisation of the food industry, with a particular emphasis around the areas that we're focused on, which is the sensor technologies in the pack house, and we'll talk about how we can, the data and what's happening there. Look, we've seen versions of this slide throughout the last 2 days, but it is still quite important to recognise and to remember why we are driving down this path towards digitalisation, this digital transformation that's taking place, and it's because we need to feed a growing population. We need to do that with better productivity. We need to maintain traceability, and we need to be able to reduce wastage in the supply chain. You know, these fundamental reasons, which mean that it really is the reason that we're talking about this technology. We show examples of what we're doing today and what we're doing in the future, and that we're on this kind of race to implement it is because we've got a big challenge together. So what can it accomplish? Again, a version of the value chain that we've seen versions of throughout the last 2 days: growing, distribution, sorting, packing, and then the retail. Now, what I want to do on this particular slide is point out that there is actually something kind of special in the sense of there's 3 places where the fruit is treated as an individual object. That's when it's picked. And the second time is at the pack house, when it goes through a sorting grading machine. And then again, when the consumer picks it up and consumes it. And that point of sorting, whether it's in a pack house or there may actually be a second time when it's repacked at the destination and goes under a sensor again, are very valuable points where we're actually looking at that individual piece of fruit. We're collecting a lot of data about it. And that's data that makes an important decision about the characteristics and the attributes of it, and makes a decision within hundreds of milliseconds whether it needs to go into class 1, 2 or 3, but also other things about how it might taste in a subgrade or a grade decision as to which market that piece of fruit needs to go into, or the storage characteristics of that piece of fruit, whether you need to immediately get it into the distribution or store. So this pack house and the repacking stage where we have sensors is very, very important. I'm going to tell you a little bit about what we're doing today and in the future. But I have to tie it back into something because almost every presentation has talked about Instagram, so I felt left out if I didn't. So here's Instagram, so I'm taking a photo of a piece of fruit, and we talked yesterday a little bit about it. We talked about that emotional connection people have with the fruit, the consumption, want to take a photo, want to put it on Instagram and Facebook. We also have an emotional connection with fruit. We take a lot of photos. We haven't started posting them to Instagram yet, but it may work out right in a minute. We're taking a lot of photos. We're taking photos of each individual piece of fruit as it rotates, getting a full 360-degree view of it so we can make decisions based on the external properties. Today we have machine vision and machine intelligence, machine learning technologies that will actually find the size and the shape, very fundamental these days, the colour, variegation properties so we can work out the colour and work out where it needs to be graded based on that. We can infer things like maturity from some of those attributes, but we can also infer defects and attributes that might change the grade, make a decision around the storage properties and things so we can route the fruit. Another example here, for an apple, we're taking photos today in colour and elements of infrared so we can see subtle defects like bruising as well. Now, we're doing this at scale, and this is where things get really interesting. So here is an example of a pack house, one of the largest, to use that as an example, where they're grading 52 million mandarins a day, 26 billion photos a day that need to be processed. We have really interesting conversations now when we go to customers
Actually, I mean, if you think that this scale is not what's happening here in South Africa, one of the top 3 by size pack houses is here in South Africa. And they're using, many sites are using some of the most advanced technology that we've got here. But we have these interesting conversations where we go in and we talk about to the customer, where is your data center? And you have that conversation a little bit now, but 5 years ago, if you went in and said, where's your data center? We need to put in 20 or 30 computers that would have looked at you blankly because they had a PC under the desk in accounts and a PC for a scanner when they get the warehouse arrival for the bins. And now we're turning out putting computers into air-conditioned rooms to keep them in control, just because we need to process this image data. So yeah, look, we're taking up to 300 or more photos of each piece of fruit, 30 meg of data. The largest sites are generating 1.6 petabytes of data per day. So we talk about 26 billion photos, maybe 10 at a sort of medium-sized site. Over a year, depending on how long their season is, we're talking about 300 or 400 petabytes of data. And so we need to work out how we handle this. We don't keep it all. That would keep a lot of disk drive companies very happy, so we actually just rotate and age it off. But there's metadata that we keep, and there's other data that we keep about each piece of fruit. So I don't know if anyone thinks I should start posting these to Instagram and get some likes, but we'll see. But external data, we talked about the cameras that do that, but we're actually also taking a lot of, collecting a lot of data from the internal properties with technology called near-infrared to shine light through, and it goes through, it reflects off the piece of fruit, and we collect hundreds of wavelengths and we make see internal properties that might be around bricks or dry matter or acid, or properties that are more defects like internal browning. And we can make those, include those in our decisions on where to route the fruit. What's in the future? Well, actually, there is new sensing technology that we'll need to apply at times to solve more complex problems than we've got today. It's inevitable that we'll have additional sensor technologies. Some of those technologies are actually being deployed outside of this industry today. Here's an example that I think is really interesting. At the start of last year, Compaq got acquired by a company called Tomra. Tomra, a publicly listed company out of Norway, and they've been in sensor technologies for many years, and they've got sensor technologies for the recycling industry, for the mining industry, for bulk food sorting, and we're actually working with them on primary research and productization of some of their technologies, seeing how they will apply into fresh fruit. This one here is the second largest diamond in the world, found in Botswana. It's Tomra X-ray technology that detected it. Before they used this type of technology, they used to run the ore with the diamonds through crushers to break it down so they could see what's in it. And that's when they worked out they were breaking down these huge diamonds like this. And now with advanced sensor technology, they can actually recover them. In fact, they're using similar technology to go through the tailings, the waste from previous inspection, and recovering diamonds out of that with this type of technology. So whether it's X-ray, whether it's laser, whether it's fluorescence, whether it's the range of technologies that we have access to, that we're looking at how to apply these pieces of fruit. So that's an example of taking sort of technology from outside the industry, bringing it in, but there's more that we can learn from other industries. I know this will be a bit of an eye chart, but fundamentally it's a McKinsey report that talks about the digitalization in different industrial segments. And what's at the top, no surprise, is green throughout all the sort of parts of the value chain for ICT, publishing, media, finance, banking industry and things. You go down, the very bottom one here is agriculture and hunting. And that's where their ranking or rating is that digitization really hasn't penetrated. That's an opportunity. It's an opportunity to get that productivity that we so desperately need to address the challenge right at the start. But it is also a reminder that some of the implementation, some of the technologies have already been discovered and implemented in some of these other segments, and we should learn from those. And they can provide us a little bit of a roadmap of what we need to do in the fresh produce, in the pack house, and throughout the value chain. So we can use examples from any of these segments, and one of the ones that we often use is around the internet. And prior to the internet, and most of the networking that was done was quite integrated. It was integrated from the device through the network through the core, right to the core servers and things, from one vendor, quite proprietary protocols. But what actually allowed and assisted in the sort of scale of the internet was the fact that the standards were created and bake-offs were created to allow vendors to make sure that their products interwork. And what this allowed is for different companies to channel their investment to focus on different parts of the problem of building the network. So people are able to sort of make sure that they built the end devices and had a stack that would communicate with any access device. Any access device was able to talk through common protocols, core routers, which in turn talk to the web servers and so on. So the use of standards to be able to define interworking and interfaces so that people could actually focus their investment on being very good at certain functions. And we believe that helps accelerate and open up opportunities, and that same learning should be applied within the fresh fruit and produce industry, and it would create opportunities for us. So right now we collect a lot of data, but we don't really share it outside of our system. We're building mechanisms to be able to extract that data, to be able to use it within the pack house, but also to be able to share it with other players in that value chain. So that might be, and we'll go through a few examples, how do we take this data and use it to feed back to the grower so that they can do their precision agriculture, because we just worked out all the characteristics of this bit of fruit, including its internals, and now we want to associate it with the actual the location that it was grown and all the other data that was associated with that about rainfall and fertiliser application and pesticides and so on, so we can make that feedback loop. But there's also a feed forward loop from the grower into the pack house that says that drone that flew down there that sort of looked and worked out a picking strategy that had information that might be useful for the pack house and pack house operators to be able to configure and operate their pack house most effectively. So there's a feed forward and a feedback to the grower. And this is only going to happen. The enabling technologies, whether some of those transactions that are in blockchain, some of those transactions are peer-to-peer, some of those that change in different ways, it will only happen when we actually start working together to sort of work out what the format is of that data and how we're going to share it with integrity. Feed forward to the distribution so that they can make the right decisions there. Feedback from distribution. Everyone here who works in that part of the supply chain knows that most often they'll receive the fruit. There'll be some sorting, maybe it's graded under our sensors again, but the feedback is usually if there's a defect or some rot or some other issues. Someone gets out their smartphone, takes some photos, writes a little bit of information with maybe a bit of batch and emails it back. It was hard to do root cause analysis of whether there was an issue with what we can learn from that. We graded it like this and we made this routing decision and it ended up bad at the point of distribution, and we need to make that more scalable. And then there's that information, one day to correlate the consumption of this piece of fruit. If we have a unique ID one day on a piece of fruit, that we can actually be able to associate when the user consumes it, they'll scan it into WeChat or whichever we know now the location of that consumer, when they consumed it, but also the environmental conditions of when they consumed it, so it might tell us why they're consuming it. But now we can also, if we capture some other information about how long it took to get there, but also if we get their eating experience feedback, we can actually say, yes, we did determine that the right attributes at the pack house, and we did make the right decision, or no, we can improve the algorithms. And that's really partly when the big data really comes into play. We start getting the learnings from all these different points throughout the value chain and working out how we can make better decisions. So at the start of this year, we gave a bit of a challenge called to set up some digital standards working groups, where we've actually started to reach out to some other players in the industry to actually sit down and talk about what these interworking standards would be for passing information back to the grower, precision agriculture, within the pack house, how the different machines and devices within the pack house can work together, but have end-to-end coordination and can create higher levels of productivity and operational effectiveness within the pack house. How we feed information through to the distribution channels and retail. And I'd welcome anyone who's interested to come up or email, and we'll work out how we can jointly work through some of these definitions. This last photo, I think, I put here is research from the University in Leuven in Belgium, and they're using computer tomography to actually take hundreds of X-ray photos and to join them together and look at the vascular structure of a piece of fruit. And you can see here how much learning that you might be able to do and work out what exactly, how the fruit's going to last and taste and things if you have this kind of information. This is still on the research side. It's not at production speeds yet, but that's maybe one of the challenges that we've got to solve. So, look, I think maybe a taster for the kind of data that we've got and some of the opportunities that we've got. Right, and we have time for Q&A.
No time for Q&A. No more questions.